So today we're going to talk about something you already know. We're talking about exponents. Or if you want to get fancy, you can call them exponents. But exponents is how you'd say. So an exponent is made of two main parts. When we have an exponent, we're going to have a base and an exponent. Okay? So the base...
We can't see it.
Ugh. Thanks for reminding me, Mikey.
You're welcome.
I had to switch this one too so you guys can see it. It should be right there. All right. So we have a base 4 and an exponent 3. And what this means is our base 4 is our, we'll put it in parentheses, it's our factor. And our exponent is how many times we have the factor. Okay, so we have a base that is our factor, and the exponent that is how many times we have the factor. So if we wanted to expand out what 4 to the third power, there's actually two ways to say this. You could say 4 to the third power. Or what I would always say is 4 cubed. Anybody know why it's called cubed? Yeah, James.
Because if it's 2 as the exponent, then it's squared.
Okay, do you know why? Huh?
Because it's 3.
Yeah, two-dimensional versus three-dimensional. What's the simplest three-dimensional figure that has the same on each side? A cube. So the reason it's called 4 cubed is you could find the volume of this cube by doing 4 times 4 times 4, which is 4 cubed, or 4 to the third power. If you were to expand it, is 4 times 4 times 4. That's what 4 cubed means. 4 times 4 times 4. All right, now I'm going to teach you how to do this in my head. Okay? Mikey thought I was going to say I'm going to teach you how to Dougie, but I'm going to teach you how to do this in your head. Okay? So, I think we got 4 times 4. We got 4 times 4? Anybody know 4 times 4 up in here?
Yes, 16.
16, okay. And then to do the 16 times 4, I'm going to tell you what I do upstairs, and then I'm going to give you an opportunity later. When I do 16 times 4, I do the 10 times 4 is 40, and the 6 times 4 is 24. And 40 and 24 are pretty nice to add together to get to 64. So that, when you have homework or something that has these two words, and I'm going to write in red so they pop. A lot of people might say, well, I'm going to solve it. We solve equations. This is an expression. 4 cubed is an expression. So the words we would use to get to this number would be evaluate or simplify. If you see those words, that means to do this. Simplify doesn't just mean do a little bit. You would do as much as you can. It's not a solution because we solve equations. We simplify or evaluate expressions. When there's no equal sign, you're not going to see the word solve. All right? Have you noticed I'm pretty big on a lot of the language? And here's why. I've said it already a million times. Math is math is communication, right? So if we're going to communicate well, the language matters. Math is trash unless we're using it to talk to people and explain the world around us, right? What's the point of just getting answers? There's kind of no point. But if we get answers to communicate things and explain to other people, that's the world around us. That's where it's money, all right? So raise your hand if you remember doing some exponents before. Yeah, you guys should all have some experience with exponents, right? Okay, so 4 cubed. Now, you know how I like to do this. I'm going to show you the most missed problem in exponents. One of the most missed problems. Maybe it's tied. Right here. You ready? So I'm going to show you this problem. In your notes, I want you to write what the answer is, what you think the most common wrong answer is, and why they got that answer, or what they did to get that answer.
It means it's 3 times 3. If it was like 3 to the third power, it'd be 3 times 3 times 3.
Yeah, and I also will see 3 to the third power as 9 sometimes, right? Which is wrong. So thank you, Neva. Thank you, Tanyan. To review for my Zoomers what Tanyan said, he said they incorrectly said the base factor 3 times 2, which is not what this means. This means base factor of 3 2 times. So someone did 3 times 2 to get 6, and that is not what that says. That says 3 times 3, right? Okay, cool. Great job explaining yourselves, guys, and talking those maths with me. So I want to look at these next two things, and I want you to write what you think the answer is, all right? And then be ready to explain if you can see kind of a generalization you can make about exponents and negative bases. So here, if I were to write this in words, it would be negative 6 squared, or to the second power, right? And I'm going to put slash cubed, because then I don't have to rewrite that whole thing. On the left, it's squared. On the right, it's cubed. I want you to write down what you think the answers are, and we're going to get together in just a moment. I'm going to restate this. Dylan said negative 6 times negative 6 is what negative 6 squared means, and that'd give us a positive answer because two negatives make a positive with multiplication division. Let's say you mess that up. That's good, because when you make a mistake and you realize you make a mistake, here, I'm going to pause this video for a second. Back to this next one. So I got negative 6 cubed, or negative 6 to the third power. I'm going to go to a zoomer. I'm looking at you, John.
He's muted.
You're muted right now. You can hold. There you are.
Negative 216.
So why do you think this one's negative? The one on the left was positive, man.
Because a positive times a negative is a negative.
Yeah, so you're saying two negatives would make the positive, and then the positive times the negative would result in the negative.
Yeah.
Cool. So thank you, John. Someone in class here, is there a way we can sum that up? Like, how do I know if my answer, when I have a negative base, so I'm going to write, when base is negative, when I have a negative base, how do I determine if my answer is positive or negative? James.
If the exponent is even, it's negative. If it's odd, it's positive.
So if it's even, it is positive.
Yeah.
And if it is odd, exponent, I should put it is negative. Now, I don't want you to memorize some rule, because we don't need the rule. We can grab that rule from understanding, right? We know that a negative times a negative is a positive, right? So what I'm saying is, we establish this rule because we see a pattern, so I want to shine light on it. I don't want you to memorize this and then apply this. I want you to understand what's working with positives and negatives, right?
Wait, even exponent is positive?
If there's even an exponent, it is positive answer. But, again, I don't want you to memorize that. I think we can make sense of that, right? If there's 4, if it's to the fourth power, negative times negative and a negative times negative, everything would be positive, right? But if there's an odd number, there's going to be an odd negative left, right? There's always going to be one more. They don't all cancel. So we can make this rule, and I want to shine light on it, but I don't want you to use this memorized rule to get answers. I think we can get there from understanding, and you don't lose the understanding. You can mess up a rule. You know what I mean? Now, this is going to get nuanced. So I'm going to try to I think in here I can screen capture part of my page. It's called the lasso function. Yeehaw! So this is what we just did. And there's going to be a nuanced difference between this. We'll pick this color for Connor because I picked on him earlier. And this. Okay, so remember on this one the base was, I should do that in blue to stay organized. So up top here, we called our base negative 6, right?
Yeah.
Okay, so who in Zoom land, one of my Zoomers, who can tell me what looks different about these green problems I wrote at the bottom? Connor, I'll let you do it since I wrote in green for you. Yeah, so unmute. What just looks different? Yeah, there's no parentheses. So, stay with me, everybody, because this is nuanced. And it's one of those math, we've got to learn symbols and what they mean in math. So, down here, here's the words. I like to show you the words for what these say first. These say the opposite of 6 squared or cubed. So if you look at the words definitely say something different. Up top, we had negative 6. Down the bottom, it reads as the opposite of 6 squared. So if we do what the opposite of 6 squared is, what is 6 squared? Everybody, what's 6 squared?
6 squared is 36.
36. So what's the opposite of 6 squared?
Negative 6.
Yes. So notice the answers are different between the blue and green here. Up top, and the words help. when it's in parentheses, this is a negative 6. This is negative 6 squared, which is a negative 6 times negative 6. Down here, this is the opposite of 6 squared, which is the opposite of 36, or negative 36. Well, we need to have a difference for math.
Wait, I think I know how it makes sense.
Okay.
What do you call the minus sign?
The negative symbol, yeah.
The negative symbol in that thing, it's not part of the 6.
Mm-hmm.
It just shows that your answer is 100% going to be negative. But up there, on the blue ones, it shows it's part of the 6.
It is part of the 6, right? So we have to have a difference. Another way you can kind of think of it is order of operations. We're squaring the 6 first before we have the negative. But
that means
this is not a negative 6 when we're talking exponents. I know it looks like a negative 6. I get it. That's why I'm pointing out like the nuance difference. This is the opposite of 6 squared.
Yeah.
If you want a negative 6 squared, you've got to throw it in the parentheses for your base.
that makes sense.
Well, I'm showing you these are two different things. If you want it to be a negative 6, it has to be in the parentheses. And this would make, up top in the blue, and I get it's like a nuanced difference. But up top in the blue, that's a negative 6 times a negative 6. Down here in the green, this is the opposite of 6 times 6.
It's 6 times 6, but with a negative.
Yes, the negative, it's the opposite of that. And so we have to have a...
So if there's no parentheses, no matter what your answer is going to be negative?
If there's an opposite in front, yes. The even and odd doesn't matter, right? Because it's the opposite of whatever that is. I don't want you to memorize that rule. I want you to understand what it's saying, and then you don't need the rule, right?
Wait, so then why is it negative 216?
On top, in the blue?
No.
Well, because 6 cubed is 216. So the opposite of 6 cubed is negative 216.
Because up here...
It's not because of the odd there. So up here, this one's negative because you have a negative, negative, negative. Down here, this 6 isn't negative. It's 6 cubed, but it's the opposite of the 6 cubed.
That makes no sense.
So I want you to focus on the language associated with the different looks.
That makes 100.
This is negative 6 squared. This is the opposite of 6 squared.
So then why is the answer... I'm confused with the negative 216.
Which one? The green one?
Yeah.
So what's 6 cubed?
6 cubed, 216.
So if it's the opposite of 6 cubed.
Negative 216. But if the top one's not opposite...
But the top one isn't opposite. So let me expand the top one out, Tannen, so you can see the difference. The top one is negative 6 times negative 6 times negative 6. You have an odd number of negatives you're multiplying, which makes it negative. Now the green one is also negative, but not for the same reason. The green one's negative because it's the opposite of a 6 times 6 times 6. So yes, they're both negative, but they're negative for different reasons.
Basically, if your not your exponent, if your factor is negative, and with
Yes.
no parentheses, it's always...
But it's not negative then. It's opposite of that then. So that's what I want. This is a negative 6. This is a 6. This says opposite of 6 squared. This is a negative 6. This is opposite of 6 squared.
That doesn't make any sense.
Well, there has to be a difference if we want a negative answer here, right? There has to be a difference. This is not a negative 6. This is the opposite of 6 squared. When there's no parentheses, it's the opposite of 6 squared.
So it's just 6.
6 squared, yeah, and you take the opposite of it. So the reason that this one's negative is because 36, the opposite of that is negative 36. The reason this one's positive is because it's a negative 6 times negative 6, which results
So then I'm
in the
confused with
positive.
216. Why is that negative both times?
Well, here it's because there's an odd number of negatives, right? These two would make a positive, but then positive times negative is negative. You good with that one?
No.
Negative times negative is positive. Positive times negative is negative.
If it's the opposite, then
But down here, it's not the opposite of the negative 6s. It's the opposite of 6 cubed. So 6 times 6 times 6 is 216.
Yeah.
Well, the opposite of 216 is negative 216. So they're both negative, but they're both negative for different reasons.
So is your answer always going to be a negative?
If it's the opposite of,
What?
if it's the opposite of, like down here,
No, like what I'm saying. So
like this one's not negative
But then that one is. So then why is the 216 negative both times?
because here there's an odd number of negatives, and
Okay.
here it's the opposite of the positive 216.
Okay, I think I'm getting it. Can I throw this in there? Okay.
Yeah, we'll pause the video though. If you focus on the language and read it using the language words, it's either a negative 6 or an opposite of. It makes the answers happen. So, I want to look at a couple other things with you that are going to be a little chiller. If we have something like 2 to the 3rd to the 4th power, we can write this multiple ways. My preference for me is it's the same thing as 2 to the 4th over 3 to the 4th. Okay? Or you can think of it as 2/3 times 2/3 times 2/3 times 2/3. These are the same. Okay? Or some people like to think of it as 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3. However you want to think about it is fine. We've got to raise 2 to the 4th and 3 to the 4th.
So
all these are the same. Same.
No, I know. What I'm saying is, like, with multiplying, I'm trying to remember. With multiplying, like, fractions, right? Don't you
Top
do,
times
like,
top, bottom times bottom.
Oh, it is?
But you can cross simplify, which is like what we did yesterday in class. But okay, so I multiply across the top, this is my personal favorite. 2 to the 4th is 2, 4, 8, 16. 3 to the 4th is a 9 times 9 or 81. So just make sure 3 to the 4th is 3 times 3, which is 9. So it'd be like 2 factors of 9. Let me show you. There's a 9 times 9 for 81. Okay. So if you get that fraction, however you want to expand it in your head, do it. But we need 2 as a factor 4 times and 3 as a factor 4 times. Last one I want to show you. You're going to be asked to find something like the number 32 with a base of 2, something like that. Now this looks confusing. The most common wrong answer here is 2 to the 32nd power. That's not what that's saying. It's saying this. I want an answer of 32 with 2 as my base. What would be my exponent?
Let me see.
Okay, so let me just, because there's going to be harder ones than this on the homework, like with a base 7. Let me show how I do this. I start just listing my factors of 2. I go 2 times 2 is, times 2 is, times 2 is, times 2 is, and I finally got there, right? And then I know the 2 is easier, but I like to then do this. I have 1, 2, 3, 4, 5 factors of 2. So my answer would be 2 to the 5th power here. That's how I write 32 with a base of 2. So how you write the number 32 with a base of 2 would be 2 to the 5th. Now I know it's easier with the 2s. I actually would just use fingers. I'd go like 2, 4, 8, 16, 32, and it'd be 5. But if you're having 7, it's going to be tougher. 7 times 7 is 49 times 7 is 280 plus.
For me because of football touching.
Oh, yeah, that's a good way to think.
I was like,
But you're doing times 7 again, 49 times 7.
I know, now it's times really.
Yeah, so I just want to give you exposure. Like that's a skill you already have. It's just if you can't figure out what it's asking for some reason, if you don't slow down and think about what it's asking, you'd have a difficult time getting there. So I'm going to upload this to the YouTubes.